Everyone, example 15, the final problem of the unit. I don't even want to do it because I don't want it to be over, right? It's so much fun. Alright guys, so again, if you thought you understood example 14, I encourage you to try this one on your own, which pretty much a lot of this is just review. The only thing that's kind of different is the whole part. So, but anyways, let's go ahead and get started. So, for the asymptotes, remember that's the one, we always start with the horizontal asymptote first because to get the degree, it's easiest to get it in standard form. So, we have to find the degree of the numerator and the degree of the denominator. So, degree of numerator and degree of denominator. Alright, which the highest exponent I see in the numerator is this 2 right here. So the degree of the numerator is 2. And the degree of the denominator, the highest exponent I see, is also this 2. So the degree of the numerator and denominator are the same, you guys. So the degree of the numerator, which I'm going to abbreviate, degree of the numerator equals the degree of the denominator. So what does that mean? Out of our 3 options, what do we have to do when they're equal? You guys are so smart. You do divide by the leading coefficients. So we divide the leading coefficient of the numerator by the leading coefficient of the denominator. So we first identify the term with the highest exponent, which we already kind of did that. It's this one. And since both of these don't have a coefficient or number in front of the x, there is secretly a 1 hiding out. So each of my leading coefficients is a 1. And 1 divided by 1 is 1. So there will be a horizontal line that crosses the y-axis at 1. Yay, this time we have asymptotes. I'm so excited already. Alright, now in order to find wholes, vertical asymptotes, or zeros, we have to do some factoring first. Okay, which, since both of these are degree 2, that means I can factor, which makes me excited because we love to factor. Alright, and both of these have 3 terms and a quadratic, so guess how we're factoring both of these? You guys knew it. Slide and divide. So again, if you know how to slide and divide, go ahead and do it. Do not waste your time watching me do it. Alright, so let's start with the numerator, which is 1x squared. There's not a number in front of this x, so I'm just going to go ahead and put the 1 in front. And then minus 6. Alright, we're going to slide a to c. So 1 times negative 6 is negative 6. So remember, we find 2 numbers that multiply to be ac and add to be our b, which the b is the 1. So 2 numbers that multiply to be negative 6 and add to be 1. You guys are so smart. It is 3 and negative 2. 3 times negative 2 is negative 6, and 3 plus negative 2 is 1. So again, we immediately put these things in a parenthesis with an x. Positive 3 means we're going to add the 3, and negative 2 means we're going to subtract the 2. And since our a is 1, we slide the a, but when we divide by a, when we divide by 1, nothing's going to change. 3 divided by 1 is 3, and negative 2 divided by 1 is negative 2. So yay, the numerator is all factored. So we have x plus 3 and x minus 2 in our numerator. Yay! Alright, our denominator, let's get going. Slide and divide again. I'm going to put a 1 in front of the x's that don't have anything since there secretly is a 1 in front of them. These two secretly have a 1, so I just went ahead and put it in front. Alright, let's do this. We're going to slide our a to our c. 1 times negative 2 is negative 2. So we find 2 numbers that multiply to be ac and add to be b, which our b is the negative 1. So 2 numbers that both multiply to be negative 2 add to be negative 1. You guys are on fire, man. It is negative 2 and 1. Man, I should just stop teaching. You guys are so smart. Alright, so we drop these immediately into our parenthesis. A negative 2 means it'll be a minus 2, and a positive 1 means it'll be a plus 1. And since our a is a 1, it's not going to impact our values because when I divide them by 1, negative 2 divided by 1 is negative 2, and 1 divided by 1 is 1. So it doesn't change anything. So On these, I'm not going to divide by the a, but technically you slide a, and at the end you divide by a, which don't forget, that's the part that people always forget. So my denominator is x minus 2 and x plus 1. Alrighty, let's get going. So our wholes, we're looking for something that is the same in the numerator and denominator. So we're looking for a factor that will cancel out. So let's see. Do we spot any common factors in the numerator and denominator? Holy hot dog, it is the x minus 2. Cross it out, chop it off. Goes away. Alright, so my x minus 2 cancels out, and that is where the whole is going to be. So there's a whole at x minus 2. So let's solve this thing real quickly. The way I solve for x, I'm going to bring negative 2 to the other side, which the way we do that is by adding a 2 on both sides. Negative 2 plus 2 cancels and turns to 0. 0 plus 2 is 2. So there will be a hole on the graph somewhere at x equals 2. So somewhere the graph will be going, and there'll be a hole somewhere, and it'll be where x is 2. So be careful though, that's where the demon cats are, so watch out. Alright, now remember you guys, once we cross out the hole, we never go back to this function. Okay, we move on to what's left over, and that's what we use to identify the vertical asymptote and the zeros. So what's left over, I'm going to write here, is x plus 3 and x plus 1. Alright, so I'm not looking back here anymore. When we find our vertical asymptotes and zeros, it must come from this one. So vertical asymptotes, we set everything in the denominator equal to 0, which my only factor in the denominator is x plus 1. Alright, and when I solve this thing for x, and when I bring 1 to the other side, I'm going to subtract 1 on both sides. 1 minus 1 cancels and turns to 0. 0 minus 1 is negative 1. So there will be a vertical line that crosses the x-axis at negative 1, and that will be the line that the graph kind of gravitates toward. It cannot equal the graph, though. The graph doesn't ever touch vertical asymptotes. Remember, it could touch a horizontal asymptote if it's being a little sneaky. Okay, but it can never cross this horizontal asymptote. Alright, the last part, you guys, the zeros, we set every factor in the numerator equal to 0, which the only thing I see in the numerator is this x plus 3. Let's do this thing. Alright, let's bring 3 over. I'm going to subtract it on both sides. 3 minus 3 cancels and turns to 0. 0 minus 3 is negative 3. So where the graph hits the x-axis, our 0, or our x-intercept, or our root, is at negative 3. So this graph will hit the x-axis at negative 3. There will be a vertical asymptote at x equals negative 1. There will be a hole at x equals 2. And there will be a horizontal asymptote at y equals 1. There is so much going on with this problem, which makes it one of the most epic problems of the day. What do you guys think? Well, it was fun, you guys. Unit 4 was a blast. I love rational functions.